Hello, welcome. This is Birdy. Welcome to a new lesson in Houdini. Today we'll continue our journey in the Pyro series in Houdini. Today we will continue the last lesson about the fire simulation and how the system works. Today we will explain the composition panel in the Pyro solver with all its parameters. So let's get started. So now let's move to the second part, which is the pyro solver for the composition. Okay, I explained the simulation in the previous lesson for the smoke simulation, so I'm not going to explain it again. But please, if you didn't watch it, please watch it, the previous lesson for the pyro. Start from the beginning to catch up with us. Okay. So now we have the composition. Of course, all this must happen if we enable the composition. If we didn't enable the composition, we will not have anything. We must have the enable composition. Okay. So let's enable it. The composition. Now, as I said, this is the ignition temperature, the temperature that make the fuel burn it and take place. Okay, so this is 0.1. So if you want all the fuel to ignite, as we see it, if you want all the fuel to instantly ignite, use a negative value like -1. So we will have now a bigger fire, a bigger flame, because we are burning all the fuel. All the fuel will be burned because of the temperature. The temperature becomes 0. So even if we don't have a temperature here, let's say the temperature is 0, we're still going to see the temperature take a place. But of course, in the absence of the temperature itself, the lifting, the bouncy lifting will be, of course, less weak, and the shape of the fire will be, or the explosion will be a little different. Okay, but as we can see here, we don't have any temperature coming from the source, but within that we still have an ignition and fuel ignition. Okay, so all this fire now, all this fire is from emitted from the ignite of the fuel. All this fire, not from the sourcing. Not from the sourcing, because we don't have any temperature is added. So let's make it 1 again. Okay, so second thing is the burn rate. So the amount of the fuel to burn per second, this ratio 0.9 mean after 1 second 90% will be burned from the fuel. Okay, so the burn rate, how much the fuel amount will be burned after 1 second, or yeah, will be burn of the fuel, the amount of the fuel to burn. Okay, to burn the amount of the fuel to burn, and this is for the fuel itself. So let's say, for example, the fuel that can be burned. For example, you have a box. In the box you have fuel. Let's make another one here. So you have this amount of fuel, or let's say this fuel. You have this amount of fuel. Okay, this is fuel. How percent of this fuel can be burned? Can be burned. So 0.9 mean 90%, 90%, 90%, 90% of this fuel can be burned. 90% of this fuel can be burned, and the other part will not be burned. We will move to the other second. Okay, it will remain. So this part will burn it, and this fuel will stay the same, and can be used in the second in the other second, the second. Okay, so this is the burn rate. So this is fuel efficiency. Control how much of the burned fuel is actually not burned. So the fuel initially, actually it's about the fuel burned itself, not the fuel. Let me explain. Now we have the fuel again. This is the fuel. When with the temperature, ignite temperature, it turned to a burned fuel, right? It turned to a burned fuel. This will be the burned fuel. Okay, this is the fuel. Let me say this is fuel, and this is the burned fuel. So when the fuel burned, it must remove, right? When the fuel burned, becoming a burned fuel, it must remove from the source of the fuel itself. Okay, so amount of zero mean all the burned fuel, this burned fuel removed from the fuel. Okay, so it's not in the fuel anymore. Okay, and one mean all the burned fuel stay in the fuel itself. يعني even will not remove from the fuel, so it will stay as a fuel. I apologize from the noise in the background. So that means the burned fuel can stay remaining in the fuel itself. Okay, it's almost looks the same, but there is a big difference between them. So I hope that makes sense. Let's continue. Now, so in this two, let's make multi-field. So in this two, we control the rate of burning fuel. Also, we control the fuel efficiency. Okay. So next we have temperature output. As I said earlier, in the burned fuel process, it emits temperature as well. So here we control how much temperature we have. If we, let's say 0.9, we should have more temperature now. Less, like 0.1. So we have the same temperature, to be honest. Let's see what's written. The amount to increase the temperature filled by for every unit of fuel consumed. Yes, as I said earlier, the amount of increasing the temperature is increasing by for every unit of fuel consumed, for every unit of fuel consumed or voxel. Okay, how much temperature increasing because of this burning fuel process. Then last but not least, the gas release. For example, the gas release, let's say you have an oven, you turn it on the oven, but you didn't make any fire. Okay, so after a while you make like a spark, so it will have something like very big explosion. Of course, don't try this at home. So let's play on the gas release to understand more what's happening on. So let's say if we just type okay, let's type 100. Let's make a keyframe. Let's go maybe here and maybe put 0. Let's make another keyframe. Maybe making this 110. So let's see what's happening. So as we can see, an explosion happened, then the fire continue. Okay, but of course we don't have to make it like 0. Maybe make it like 5. Okay, something like this. Also we can to have something like explosion, we can make the scale here, for example 1, and later we have 0. So we're not going to have a fuel to ignite anymore after the explosion, so it will be something like just explosion, and it will disappear. All will disappear, as we can see here. Okay, so this is the gas release. Okay, let's make it to the default. I don't need any keyframe here. Also make as the default one. Okay, so next we have here something called the flame height. Okay, the flame height doesn't change the shape of the simulation, but only it change the height of the flame. Yeah, here we have flame here. If we make it 1, we'll make the flame less height. Maybe here, maybe if I increase it like this, as we can see, we control it. We control the flame only. We control the flame only from this number, the height of the flame. Okay, the height of the flame. If the flame will be here or will be here or will be here, but it doesn't change the simulation itself. The simulation remains the same. Okay, then we have the cooling field. The cooling field for the flame. The cooling field that it cooling the flame and turn it to cooling field by the temperature field, meaning 0 temperature. Let's here, for example, we have 0 temperature here. So any voxel that has 0 temperature will have a 0 temperature for the flame or cool it. Okay, and let's say here, yeah, and the temperature field that have 1, it will not have any effect for the flame to cool it. Okay, so as we can see here, this is the range for the temperature cooling field. Okay, and this is the 0. This is the strongest, and this is the weakness. After one temperature, there is no cooling field. There is no cooling on the flame itself. So let's continue for the smoke now. As we can see, simply smoke is emit smoke. If you want to have emitting smoke in the simulation, you check the emit smoke. If you don't want to have smoke, you simply don't emit smoke. Same as oven fire, it emits fire without smoke, right? So as we can see here, so create dense smoke mean you will have dense smoke. Okay, as we can see here, we have very dense smoke, and usually dense smoke for explosion more. Okay, also you have smoke amount. If you put here 0, you're not going to have any smoke, same as if you uncheck the emit smoke. Okay, so here is the heat cutoff. So the heat cutoff, as we can see from its name, it's heat cutoff, meaning when the value or the amount of the heat field is 0.2 or below this number, it will convert to smoke. From heat to smoke, as we said earlier, heat is a flame, right? And this is a blend amount between both of them, between the heat and the smoke. Then we have gas. Usually gas and temperature, no one didn't see anyone change on those two parameters. Then we have fuel. Last thing is the fuel. Let's check the fuel and see what's doing. If we check the fuel here, so this is a fuel field in the simulation. As we can see, it doesn't change, it's just added because of the fuel add mode, right? So let's change it to advect fuel and press play again. As we can see now, the fuel start to expand and become much bigger, and the advect happened with it too, right? So as we can see, it expand and move up, right? So this is the advect fuel, and of course if you check advect fuel, you will have bigger explosion or bigger fire. Okay, and that was it for this lesson. I hope you enjoyed. If you have any question, please type it in the comment section below the video. Also, don't forget to like the video and subscribe for the channel and share it with your friends. And I see you in the next lesson. Have a good day.